Across the sands of Saudi Arabia, something extraordinary is rising. A plan so extreme that engineers around the world are questioning whether it can even be done. In the heart of Riyadh, blueprints are unfolding for a structure that would make the Burj Khalifa look small. The project is called Rise Tower, and when built, it would reach 2,000 meters into the sky. Twice the height of the world's current tallest building. Twice the weight of engineering logic. But here's the real question. How do you build something that touches the clouds without collapsing under its own ambition? Let's find out. Over the past decade, Saudi Arabia has been rewriting its future. Under Vision 2030, the country is racing to reinvent itself, shifting from an oil-based economy to one powered by innovation, tourism, and technology. The goal is not gradual change, it's transformation at a scale the modern world rarely attempts. Projects like NEOM, The Line, Qiddiya, and the revived Jeddah Tower have already grabbed global attention. Each one pushes the limits of design, cost, and human imagination. Among them, Rise Tower appears to be the boldest, the project that could define a new era of engineering in the desert. When the world's tallest building opened in Dubai in 2010, it changed the skyline forever. Saudi Arabia doesn't want to compete with the past. The kingdom wants to redefine what's possible for the future. Rise Tower is planned for northern Riyadh, in a new district often called the North Pole. The concept envisions a 2-kilometre skyscraper with roughly 678 floors, a vertical city stacked into the sky. When completed, the tower would be visible for nearly 100 kilometres across the desert, becoming a global landmark for the region. Early sources link global architecture firms like Foster & Partners to the design, while others mention HKS architects. Nothing is finalised, and that uncertainty keeps the world watching. Is Rise Tower a bold concept meant to attract global investors, or a blueprint waiting for the green light to rewrite engineering history? For context, the Burj Khalifa in Dubai stands at 828 meters. Jeddah Tower, still under construction, targets roughly 1,000 meters. Rise Tower would leap far beyond both, nearly 2 full kilometers. At that height, the structure enters a zone no skyscraper has ever tested. Air pressure drops, wind speeds climb, and even Earth's curvature starts to matter. Every floor adds weight, and every meter magnifies the challenge. Engineers estimate the building would contain enough concrete and steel to construct a mid-sized city. Elevators could travel more than a full minute from base to top. From the observation decks, passengers might look down on airplanes descending into Riyadh's airport. It sounds like science fiction, but the planning is very real. Every record-breaking tower begins with the same question. How deep must you dig before you rise? For a building like this, foundations are everything. Engineers would excavate a pit dozens of meters deep, driving thousands of steel-reinforced piles into solid limestone bedrock. Above them, an enormous concrete raft would be poured, likely one of the largest continuous pours in history. That base must do more than hold weight. It must absorb vibration, resist earthquakes, and distribute the tower's load evenly across the shifting desert soil. The pressure on each square meter would be almost unimaginable. A single design error at this stage could doom the entire project before the first beam reaches sunlight. Now imagine standing halfway up, a kilometer above the ground, when desert winds begin to roar. At that altitude, gusts behave differently. Airflow becomes unpredictable, creating invisible waves of force that slam into the tower's frame. To survive those forces, the structure must move. Engineers rely on tuned mass dampers, massive suspended weights that sway in the opposite direction of the wind to cancel motion. Others reshape the tower itself, tapering, twisting, or opening gaps that redirect air and reduce drag. Every curve and contour matters. A simple change in geometry can decide whether the building sways gracefully or tears itself apart. As the tower climbs, the air changes. Oxygen levels thin, humidity drops, and temperature swings dramatically between the ground and the upper floors. The building must generate its own artificial atmosphere. Engineers would divide the structure into climate zones, each one balanced for temperature, pressure, and oxygen. Sophisticated sensors would constantly adjust airflow to keep the environment stable, no matter how harsh the desert outside becomes. Without these systems, doors could jam from pressure differences, and even breathing could become difficult at high altitude. Comfort at 2,000 meters has to be engineered from the ground up. Height brings another problem. How do you move tens of thousands of people across hundreds of floors efficiently? Traditional elevators rely on steel cables that grow dangerously heavy and flexible beyond a kilometer. Cableless elevator systems, powered by magnetic levitation, are being developed to handle extreme height. They can move vertically, diagonally, or even horizontally between cores. These lifts turn the tower into a multi-directional network, where residents can transfer between zones rather than travel the full distance in a single trip. Designers also envision sky bridges, connecting entire neighborhoods within the structure, forming a complete vertical city. Every innovation introduces risk. A power failure or mechanical fault at altitude is not an inconvenience, it's an emergency. Before any steel is raised, engineers will build the tower inside a computer. Millions of simulations will test how it reacts to windstorms, earthquakes, and thermal expansion. This digital twin allows experts to refine the design long before construction begins. Once the real tower rises, thousands of sensors will track stress, temperature, and movement in real time. Data will flow into a central control system that adjusts dampers, climate zones, and power loads automatically. The building learns its own rhythm, predicting strain before it becomes danger. Rise Tower imagines a world contained within one frame. Homes, offices, hotels, schools, clinics, and gardens would stack from the ground to the clouds. Upper levels could host glass-domed parks with panoramic views of the desert. Middle zones might serve as business districts or residential neighborhoods. Transit systems would connect these layers so people could live, work, and relax without leaving the structure. But life above the clouds demands more than architecture. Designers must consider human health, social connection, and the psychology of vertical living. People need sunlight, community, and space to move. These elements must be built into the design, or the tower risks feeling like a machine rather than a home. Ambition carries a price. Early estimates place the project around $5 billion, but that figure likely represents only part of the development cost. Analysts expect the final number to climb once infrastructure and logistics are added. Some reports predict construction could begin in 2026, though no official confirmation exists. Projects of this scale depend on stable funding, materials, and workforce coordination. A single disruption in supply or finance could delay the schedule for years. Every decision, structural, financial, or political, will decide whether Rise Tower becomes an icon or a cautionary tale. For clues about what lies ahead, look to the Red Sea coast. Jeddah Tower, planned as the world's first 1-kilometre building, has faced years of delay but is now active again. Cranes have returned and construction is moving forward. Its story is both inspiration and warning. Vision created momentum, but politics and money brought it to a standstill. Now, determination is bringing it back to life. Saudi Arabia seems unwilling to abandon its tallest ambitions, and that persistence could carry over to Rise Tower. If Jeddah Tower succeeds, it will prove that the kingdom can finish what it starts. If it falters again, investors may grow cautious, and the dream of 2 kilometres may stay trapped on the drawing board. Even as a concept, Rise Tower has already influenced architects and city planners worldwide. Engineers in Asia, Europe, and North America are studying its feasibility. A completed structure of this height would require new materials, new codes, and new standards for everything from wind testing to evacuation systems. Success would change the blueprint of urban life. Cities could expand upward rather than outward, reducing sprawl and redefining the limits of density. But every advance brings greater risk, and at this altitude, error has no margin. Rise Tower signals a new chapter in human construction. The plans are daring, the math is fragile, and the ambition is sky high. Whether the tower rises from the desert or remains a vision on paper, it has already shifted the world's imagination toward what might come next. The foundations are being planned, the bids are open, and the idea refuses to fade. Saudi Arabia has made its intention clear: to build beyond boundaries and reach heights no civilization has reached before. If even part of this vision becomes reality, the world's next great skyline may not belong to New York or Dubai, but to Riyadh. Thanks for watching. We'll see you next time